Okay, we'll soon commence. Hold on a minute. We'll be experiencing network challenges. So soon now we'll start the class by answering some questions, and this question may guide you to answer your examination question you might see. So, a minute. We'll commence soon enough. Soon enough. We are going to answer some of these questions and see how you might use this knowledge to answer your own question where you meet something similar. So hold on a minute. Hold on. If you can hear me, you can. Babe, I think okay, you can hear me. So so this chemistry, basic or fundamental chemistries. I'm also thinking by 100 level students in various. It has different names depending on the school. So some call it CHM101, some call it CHM101 or 111, depends on the characterization by the school. So soon we're going to start by answering question 1 to 20. If there's time, we might do more than that. So we'll start soon enough. Okay. It's a question, attempt or question, write the correct answer only. Instruction C, you give you some constant, like 1 nanometer, Planck constant, speed of light, and some atomic masses, hydrogen, carbon, oxygen, sodium, nitrogen, calcium, and chlorine. So you have to apply these constants, try the question where needed. So let's begin by answering question 1. So write a balance equation for tetraoxosulfate 6 acid and sodium hydroxide. So from the chemical formula they wrote on the question, that is not the chemical formula for tetraoxosulfate 6. So we're going to write the correct one as sodium hydroxide, write the equation and see how we're going to formulate the product. So to obtain the product, there's something you need to know. You need to know who are cations and who are anions. Who are cations and anions. So cations are positive ions, while anions are negative ions. Cations are the positive, while the anions are the negative. So for every chemical formula you have, not always, but mostly, the chemical formula must contain, or compound must contain, anions and cations. Like the tetraoxo acid, which is H2SO4. That is the correct formula. H2SO4. That is the correct formula. So let's try to answer question 1. A balance equation for tetraoxo acid and sodium hydroxide. So H2SO4 is the right formula. So if I want to write that, I will have H2SO4 plus sodium hydroxide, NaOH. That's the chemical symbol for sodium hydroxide. So how do I formulate the product of these two? To do so, I will identify the cations and the anions. The cation here is hydrogen, while the anion is sulfate. The cation here is sodium, while the anion here is hydroxide. So if you are balancing the equation, the positive will combine with the negative. But while doing so, you must exchange their combining powers. Combining powers of an element is what we call radicals, or valency. Combining power of an element is referred to as valency. So what is the valency of hydrogen? We know hydrogen is in group 1, it has 1 valence electron, while sulfate is a radical, SO4. It has a valency of, let me put it, it has a valency of -2. Sodium is 1, hydrogen is 1, hydroxide is -1. So in this case, the sulfate, which is negative here, will combine with the positive here. By doing so, I'm going to exchange their combining power, which is their valency. So let me give you a sample. We're going to have sodium. It has a combining power of 1, while sulfate, it has a combining power of 2. So if I exchange their valence electron, I'm going to have Na2XO4. So this is one of the products that will be formed, NO2XO4. So I'm going to have Na2XO4 plus, so what is the valence or the combining power of hydrogen and hydroxide, which is the positive and the negative we are here to use? Hydrogen, combining power of 1, hydroxide, combining power of 1. So if I should exchange, we're going to have HOH, which is something as H2O. So the next product now is simply plus H2O. So all we need to do is to balance this equation, because writing is not enough. We need to balance it. So by balancing it, I have to consider the atomic number, or the number of mole of just the molecules of each atom or element. Like we go to the reactant, sodium is 1 molecule, the product is 2. To correct it, I will put 2 here in front of the sodium. That means the 2 is affecting sodium, is affecting oxygen, is affecting hydrogen. That means we're having a total of 6 oxygen. Because 2 times 2 here in the sodium, it gives us 2 oxygen. In the H2SO4, we have 4 oxygen. A total of 6. So in the product, we already have 4 in the sodium sulfate. To correct it, I will just add 2 here. The hydrogen is also 4. 2 times 2 will give us 4. So this is a question. This is a solution to question 1. Na2SO4 plus 2H2O. That is the solution to question 1. Question 2 is said 25 cm cube of hydrochloric acid Okay. So as I was saying, if you see acid-base titration is prepared, from the question they said 2.3 grams was dissolved in 250 cm cube. So when you dissolve it, it's going to form a solution. From there, we can get the volume of the pipette needed for the titration, which is always 20 or 25 cm cube, depending on the design of the pipette, whether it's American standard or it's a British standard. So that is what to So it depends on as I was saying before, we have a network interruption. I hope you can hear me, David. Can you hear me? Hello, David. If you can hear me, please speak up. So this is the salt, quantity of the salt, which is 2.3 grams. From here, we are going to get our volume of pipette, which is our VB. It's a standard value. It's always 20 or 25 cm cube. That's the volume of the pipette. It's always 20 or 25 cm cube. So by dissolving the 2.3 into the 250 cm cube of solution, we are going to get the setting concentration of the base. So how do we determine the concentration of the base? By dissolving this whole thing. So to do so, we are going to apply a formula that says given mass over molar mass is equals to volume over 1000 times the concentration, molar concentration. Because by dissolving the 250 centimeter cube of water into 2.3 grams of the salt, it's going to form a certain concentration. So we're trying to determine that concentration and the concentration of the solution. So by doing so, I first of all get the molar mass of sodium hydroxide. Molar mass of NaOH. That is Na plus O plus H. Now, if you go back to the question, we are given atomic masses. Sodium is 23, oxygen is 16, hydrogen is 1. So I'm going to use that to calculate the molar mass of sodium hydroxide, which is 23 plus 16 plus 1. That will give us 40 grams per mole. So that is the value of the molar concentration I will fix here. Don't forget the mass is given to us as 2.3. The volume is 250 cm cube. With that, I can now find molar concentration of the base. So I'm going to have 2.3 over 40 is equals to 250 over 1000 times molar concentration, which are called MC, molar concentration. So if I make the molar concentration the subject formula, what are we going to have? So my molar concentration will give us 2.3 times 1000. We achieve that by simply cross multiplying 40 times 250. So my MC will be what? So multiply and divide. I'm going to have 0.92 mole per dm cube. Mole per dm cube of sodium hydroxide. 0.92 mole per dm cube of sodium hydroxide. That is what we are going to achieve as our molar concentration. Let's go back to the question and see. So the question says we should calculate the molar concentration in grams per dm cube of the acid and molar concentration in gram per dm cube of the base. So please, there are two things you need to know. There are two types of concentration. We have molar concentration and we have mass concentration. The molar concentration is measured in mole per dm cube, while the mass concentration is measured in grams per dm cube. So question 3, question 3 also. So how do we calculate the concentration of the acid in grams per dm cube? So first of all, let's take the mathematical formula of concentration in grams per dm cube. Let's get the mathematical formula for concentration in grams per dm cube. That is mass concentration, that is concentration in grams per dm cube, measured in grams per dm cube, is equals to molar concentration measured in mole per dm cube times molar mass measured in grams per mole. So this is a mathematical relationship for mass concentration, which is in grams per dm cube. But if you go back to the question, we have not gotten the molar concentration of the acid yet. The one we got was that of the base. So how do we get the one of the acid? So to do so, we are given volume of the acid is, if you look at the question, we have 25 cm cube of hydrochloric acid, that of the acid, was titrated against 20.0 of the base. So the of the molar volume of the acid is 25, volume of the base is 20. The molar concentration of the base, we calculated for it already, is 0.92. So we're going to use that to calculate the molar concentration of the acid. From there, we get our mass concentration. So we have our VA is 25, our VB is 25 cm cube. Our VB is 20 cm cube. Our CA is unknown. Our CB is 0.92 mole per dm cube. Mole per dm cube. So from here now we can calculate the concentration of the acid by imputing the general formula that says CaVa over CbVb is equals to Na over Nb. Now if I go back, you can see from the data I've written, I don't have Na and Nb. So how do I get my Na and Nb? We can get that by writing the chemical equation between sodium hydroxide and HCl. So let's do that. HCl plus sodium hydroxide. In the same manner, identify the cations and the anions, positive, negative, positive, negative. So the positive one will combine with this negative to form what? will form H2O plus positive one combined with this negative to form sodium chloride. So if you look at the equation, it's already balanced. So the point is, the mole ratio of acid to base is 1:1. It simply means that my Na is 1, my Nb is 1. That means the number before, how many moles we have here? 1. How many moles we have here is 1, even though we are not writing it. The Na is 1, the Nb is 1. With that, I cannot find the concentration of the acid. Cannot get the concentration of the acid. So let's do that. So I'm going to have Ca, I don't know, times 25 over Cb, 0.92 times 20 is equals to 1/1. So my Ca will be 0.92 times 20 times 1 divided by 25 times 1. Our Ca will be what? 0.92 times 20 divided by 25. That will give us 0.736 mole per dm cube. So this is now the molar concentration of the acid. With that, I can determine the mass concentration of the acid. Let's go back to the mathematical expression for mass and molar concentration. This is the relationship between both of them. We said mass concentration equals to molar concentration times molar mass. Yes, times molar mass. So what is the molar mass of the acid? Don't forget the acid was HCl. So let's get the molar mass of the acid. Let's get the molar mass of HCl. As you know, it is the sum of individual atoms, which is H plus Cl. My H is 1, my Cl is 35.5. If I add up, I'm having 36.5 grams per mole. So with that, I can now find the mass concentration now. Mass concentration, molar concentration is 0.736 times 36.5. What would that give to us? That will give us 0.736 times 26.5. That will give us 26.864 grams per dm cube. That's not the mass concentration of the acid. Then let's go back to the question. We also asked to find the mass concentration of the base also in grams per dm cube. Don't forget what the base is. The base is, they gave us okay, I saw your message, so let's take it all over again. The question 2 and 3, and that including 4. Let's start it all over again. Question 2, 3, and 4. So let's take the question 2 again. You say you can't see. I hope you can see it now. Okay, so okay, you can invite your friends to join also. So let's take the question 2 again. because you said you couldn't see anything. Let's take it again. You say, okay, let's go read the question. Say 25 cm cube of HCl. That is the volume of the HCl is an acid. That represents the volume of the acid. Was titrated against 20 cm cube of the base. That is the volume of the base. Solution that contain, the base now contain 2.3 grams in 250 cm cube of solution. We are asked to calculate the concentration of the acid from this expression. Okay, so how do we get the concentration of the acid? To get it, we need to first of all get the concentration of the base. Without the concentration of the base, you cannot get the concentration of the acid because the base was given, the data of the base was given 2.3 grams in 250 cm cube. So let's get the concentration of the base. So the mass, to do that, we are going to use a mathematical formula that says given mass, the given mass now, which is the 2.3 they gave to us, over the molar mass of the base, which is sodium hydroxide. Molar mass is equals to volume of the base, which is the 250, over 1000 times molar concentration of the base. So without getting the molar concentration of the base, you cannot get the molar concentration of the acid. So what is the molar mass? Molar mass now, molar mass of sodium hydroxide. I will just sum them up, which is sodium plus oxygen plus hydrogen. If you go back to the question, we are given some atomic masses. They will give you some atomic masses here. You can see that from there we have hydrogen is 1, carbon is 12, oxygen 16, sodium 23, nitrogen 14, calcium 40, chlorine 35.5. So place of sodium I'm putting 23, oxygen is 16, hydrogen is 1. For some, what are we having? 40 grams per mole. That is now the molar mass of the acid. So we are going to fix this value here now. We are going to fix this value now in place of the molar mass. Let's fix it here. And we have been given the mass as 2.3. The volume is 250. So with that, we cannot calculate the molar concentration. So let's fix it. We're having 2.3 over 40 equals to 250 over 1000 times molar concentration of the base. So if I simply cross multiply and make the molar mass the sodium formula, I'm going to have molar mass, sorry, molar concentration, molar concentration is now 2.3 times 1000 divided 40 times 250. So if you multiply divide, what are we going to have? So let me multiply from here, 2.3 times 1000 divide 250 divide 40. That will give us 0.23 mole per dm cube. 2.33 mole per dm cube of B. This is of the base of B, not of the acid. So with this, I can calculate the molar concentration of the acid, because from the question, we are given the volume of the acid as 25, volume of the base as 20. We now have the concentration of the base now as 0.23. With that, I can get the concentration of the acid. So which will give us our VA, volume of the acid from the question, is 25. Volume of is 20. Concentration of the base is 0.23. That's what we just calculated. The concentration of the acid, I don't know. That's the question mark. So this formula now, we're going to apply general formula in acid-base titration that says CaVa over CbVb is equals to Na over Nb. But if you look at the data, we don't have Na and Nb. You can only get your Na and Nb from a chemical equation. So let's write the equation between sodium hydroxide and HCl. Let's do that. We're now having HCl plus sodium hydroxide. What will it give to us? So to predict the product, you consider the cations and the anions. The cations are the positive ions, while the anions are the negative ions. So here is positive, here is negative, chlorine is negative, sodium is positive, hydroxide is negative. So the point is, the positive here will combine with the negative here to give me what? Sodium what? Chloride plus negative here will combine with this positive here to give us what? H2O. Give us sodium chloride and the H2O. And if you look at the various balance equation is balanced. That means here is 1, here is 1. And the number of mole of the acid that took place in the reaction is 1. The number of mole of the base that took place in the reaction is 1. That means my Na is 1, is the mole ratio of the acid. My Nb is also 1, which is the mole ratio of the base. With that now, I can now fix the data into the mathematical formula. So this mathematical formula to get our concentration of the acid. So let's do that. I'm going to have Ca, which is what I'm looking for. We're going to have Ca times 25 over Cb, which is our 0.23 times 20 is equals to 1 over 1, which is the mole ratio of the acid to the base. So my Ca will give me 0.23 times 20 times 1 divided by 25 times 1. So my Ca is equals to what? So if I multiply 0.23 times 20 times 1 divided 20, so that is solution to the question 2. We are asked to find the concentration of the acid in mole per dm cube. So you calculate the concentration of the acid now in grams per dm cube. There are two types of concentration. We have one in mole per dm cube, which is what we call molar concentration. We have another one we call grams per dm cube, which is what we call mass concentration. So what's the relationship between the molar concentration and the mass concentration? There's a mathematical relationship for it that says mass concentration is equals to molar concentration times molar mass. That's the relationship. So we are looking for the mass concentration. We already gotten the molar concentration already, which is our 0.184. That's the molar concentration. So let's get our molar mass of the acid. So I will say molar mass of ACl, like I said, is sum of each element, which is H plus Cl. What's the atomic mass of hydrogen is 1, chlorine is 35.5. From the data they gave to us earlier, that will give us 36.5 grams per mole. Grams per mole is the unit of molar mass. So with that, I can now find the mass concentration. So mass concentration is equal to 0.184 times 36.5. What would that give to me? 0.184 times 36.5, that will give us 6.716 grams per dm cube. That's the concentration of the acid now, 6.716 grams per dm cube. We've got two of it. We also have to calculate the concentration of the base also in grams per dm cube. That means it's also the mass concentration of the base. So how do we do that? The same formula, mass concentration in molar concentration times molar mass. So let's go back and know the molar concentration of the base. We've got that already. Molar concentration of the base was, yes, 0.23. That's the molar concentration of the base. So let's use to find our mass concentration. And the molar mass of the base is already 40. It's there already. So we're going to have mass concentration is equals to molar. The same formula, concentration times molar mass, which is now 0.23 times 40. The two data are there already. All you need is to multiply 0.23 times 40. That will give us 9.2 grams per dm cube. This is now the mass concentration of the base, 9.2 grams per dm cube. I hope you can hear me.
Recording in progress.
So I hope you can hear me. So let's go to question. Let's go to question 4. If I'm not mistaken, it'll be question 5. So if you have any observation or question, you can put it as a message or you can ask directly. So let's go to question 5 and see what we have there. Yes. Okay, question 4. Dash and dash are apparatus for heating. These are common things we use in laboratories for dryness. Maybe you want to heat something to dryness, or you want to heat something to combust a particular compound, or to decompose a particular compound. We use our crucible, which is the device we put where we put the salt. We have our triple stand, we have our wire gauge, we have our Bunsen burner also. So those are the materials we use for heating. About 5 of the 6 of them. Your crucible, your tripod, your triple stand, your Bunsen burner, your wire gauge, and what did I mention earlier? Yeah, those are some of the things we use for heating. So you can mention any of them, any of the 2. Now, question 5 says, to what group and period does an element with atomic number 13 belong? So let's first identify who the element is. With atomic number 13, that should be aluminium. Aluminium. That is the element with atomic number 13. So to determine the group and the period, all you need to do is to write the electronic configuration of aluminium. That's the way to determine group and period. Either you use the SPDF notation or you use the atomic structure pattern. SPDF notation on the atomic structure. For aluminium, I can write it as 2A3 based on the atomic structure. It's 2A3 because the first orbital is the first shell will take 2, second shell will take 8, and the third shell will take the remaining 3. So, or I can use the SPDF 1x2, 2x2, 2p6, 3x2. That is, if I calculate, this is 10, 12, then 3p1. 3p1. So, to what group does it belong now? It belongs to group 3. Belongs to group 3 and also period 3. You can also use it to determine the period also, not only the group. By writing 2A3, that is belongs to group 3. Or I can label it as 1. How many orbital how many shares does it have? It's 3 shares. 1, 2, 3. That means it's in group 3 and also in period 3. The period just count the number of shares that determine the period. So aluminum is in group 3 and also period 3. To what group and period? Group 3 and period 3. Then question 6, it says, what is the maximum number of electrons that can be fed to the principal quantum level for which n equals to 6? There are 2 formulas anyway, so you need to be very careful. We have total orbital in a shell. It has a different formula from the maximum number of electrons a shell can take. So for a total orbital in a shell, the formula is this. Total orbital total orbiter in a share. The formula is simply n squared. Total orbiter, where maximum electron, maximum number of electron in a share, maximum electron is simply 2n squared. So it depends what the question is asking will determine whether you have to use the first formula or you have to use the second formula. So if I go back, let's see which of them you're asking for. You're asking for the maximum number of electron when n is 6. All you need to do is to impute my formula now, which is this. So we are using this 2n squared. Our n is 6, don't forget that. So I'm having 2 brackets 6 squared, which is 2 brackets 6 squared is 36, which is also 6 times 6. Bracket means times. So if I multiply 2 by 36, that will give us 72 electrons. That is the answer. It will take a maximum of 72 electrons. I hope that's clear. Question 7. It says mention the bond type existing in hydrozonium ion and carbon 2 oxide. The bond that exists between hydrozonium ion that exists in the molecule of hydrozonium ion and carbon 2 oxide. The hydrozonium ion, the bond there is, you can see hydrogen and the oxygen, they are non-metal, though it's a positive ion, so it will go in with dative covalent bond. That is for hydrozonium. While carbon and oxygen are 2 non-metal. When 2 non-metal come together, what you have is covalent bond. So the first one is dative covalent, while carbon 2 oxide is covalent bond. So these are the types of bond. When you have 2 non-metal coming together, is covalent. When you have a metal and non-metal coming together, is ionic or electrovalent. So when you have metallic objects or mentals, we deal with a metallic bond. So the answer is dative covalent and covalent bond. It said draw the Lewis dot structure of sulfur oxide. So the Lewis dot structure is for sulfur oxide. Sulfur oxide is this. It will follow a linear shape because of the 2 molecules of oxygen. So it will follow a linear shape, and we have X, as the case may be, which is for sulfur. I will have X for sulfur. So I'm having X here as sulfur. So we have oxygen and oxygen. We follow a linear shape. And the angle now between the bond now is 180 degrees. So we follow in linear shape. There are different types. We have tetrahedral, such as methane. Methane is CH4. If you draw that, it's going to give you tetrahedral shape. We have ammonia, NaOH3. We have, this is a trigonal pyramida for ammonia. While we have water. Water is different. You can see water is different for SO2. Because the O here is single, while here is O2. So you cannot say water is also linear. The angle is 180. No. Water will undergo what we call bent shape. Bent shape. That is the difference between them. So take notes. For CH4 is tetrahedral. For NH3, such as ammonia or anyone that has NH3, is trigonal pyramida. Trigonal pyramida. While water molecule will undergo bent, while sulfur oxide, carbon oxide, sulfur carbon oxide will undergo a linear shape. So that is the answer to that question. Say arrange the elements in order of increasing electronegativity. In order of increasing So how do you determine the electronegativity of elements? We use what we call Pauling scale. Pauling scale. To determine the electronegativity of any element you want to determine. For instance, it starts from fluorine. We all know fluorine is the most electronegative element. So fluorine have, through the Pauling scale, fluorine have a scale rating of 4. Then oxygen have a scale rating of 3.44. Then nitrogen, they are about 7 also. Nitrogen is 3.04. Then which other one? Phosphorus. Phosphorus is 2.10. Yeah, we also have the likes of chlorine. Chlorine is 3.16. So you can see. Let's go back to the question and see which of whether it's increasing or decreasing. Say I read the following order of increasing. So who has the highest polling scale there from what I've written is oxygen, followed by nitrogen. Phosphorus is 2.1. So that means I'll find phosphorus first. That means phosphorus is less than nitrogen. Nitrogen is less than oxygen. Why? This is 2.1, which is less than what? 3.04, which is less than 3.44. So through the Pauling scale, you can determine the electronegativity of some elements. So it's just good you know some of them, you can memorize them. Yeah, about 7 or so, with the least one being seems to be sodium, 0.7 now, 0.97 if I'm not mistaken. So through the Pauling scale, you can determine the electronegativity of some elements. Then I say the contribution of Wilhelm Röntgen, discovery of atomic structure is X-ray. This guy work on X-ray, discovery of X-ray. We have to improve the atomic. You have to improve in determining atomic structures of many elements, including it's also applicable in medical field, such as to determine our internal organs and other stuff. That is that. It work on X-ray. X-ray is the correct answer there. Now, it says ammonia readily precipitates in coordinate covalent bonds. Ammonia readily precipitates in coordinate covalent bond. So let's get what ammonia is. Ammonia is NaOH3. It's ammonia. If it precipitates, that means it will form ammonium, NaH4+. You form ammonium if you undergo precipitation to form a PPT. Ammonia itself, if you are doing tests for cations and anions in qualitative analysis, for ammonia itself, maybe you used to test it for, you can use it to test for chlorine, you can use test for sodium hydroxide, and other anions. So for it to undergo precipitation, that means it will become ammonium. It will become ammonium. So by forming ammonium, the structure of, I want to draw the structure of this ammonia, it becomes this. It becomes something of this nature, structure of ammonia. So ideally, so ammonium itself is this, and here is H, here is H, here is H, here is H. You can see there's a difference between both of them. So for ammonia to ammonium, the reason is that it has a lone pair. It has a lone pair of electron on the hydrogen atom. There's one, it's supposed to be an hydrogen atom here, so you have a lone pair of electron to the hydrogen atom. That is the reason. It has a lone pair of electron to the hydrogen atom. So it's electropositivity. We have electropositivity, we have electronegativity. Electropositivity decreases across the period. That is true, because it moves from hydrogen down to chlorine or neon, which are all group H, which is noble gas, or the group O, they have no charge. So it will decrease across the period and increase down the group. So the answer is decreasing across the period and increasing down the groups, because hydrogen group 1, group 1, group 2, group 1 and group 2 elements, they are electropositive metals. So if it's moving from there through the period, it will now move to the likes of chlorine, which is electronegative. So it's decreasing across the period and increasing down the group. So calculate the molar mass of calcium trioxocarbonate 4. So I need to calculate the molar mass of calcium trioxocarbonate 4. The first thing I will do is to write the chemical formula of calcium trioxocarbonate 4. So how do I write it? Without writing the formula correctly, I cannot determine the molar mass of calcium trioxocarbonate 4. So to do so, I will get the combining power of calcium. Calcium is already written like this, it's plus 2. It has the combining power of 2. Why is it so? From the first 20 elements, calcium is 20. So if I arrange it around the share, atomic share, look at what we are going to have. The first electron share must have 2 electrons. Second electron share will have 8. The third electron share will also have 8. So if you can count now, 2, 8, 8, that is 18, remaining 2 electrons, which is this 2. That's why we are having this one as 2. That is why calcium is plus 2. What about carbonate, CO3? You also have it's a radical. Radicals are a group of atoms acting together as a single unit. So anytime you are combining carbon to oxygen, it has a valence electron of -2. So carbonate also has valence electron of 2. So if I combine these two now, it will form the calcium trioxocarbonate 4. Since both of them have 2, 2 as a valence electron, let me show you now. Calcium is 2, carbonate is 2. So they will cancel out to give us 1:1. So if I combine them now, what am I having? I'm having ratio 1, CO3 ratio 1. So this is now the chemical formula of calcium trioxocarbonate 4. So for me to find the molar mass of CaCO3, like I said earlier, is the sum of individual atoms. I'm having Ca plus C plus 3O, because we have 3 oxygen here. It's 3 that is present. So I'm having Ca plus C plus 3O. So what is the atomic mass of calcium is 40, plus carbon is 12, plus 3 brackets 16, oxygen is 16, which is 40 plus 12 plus 48. That will give us 100 grams per mole. Always put the units, otherwise they will deduct, it's a German objective, they might deduct mark from you without the SI unit. So the answer is 100 grams per mole. That's the molar mass of calcium trioxo 4. Then the next question, question 14. So write the electronic configuration of the following elements. Silicon 16. Always look out for it. Check if the element has ion. Ion are charges possessed by elements. It has a charge of +1. Always look out if it's a neutral metal or element, or it has an ion. The silicon is neutral, just no ion, but the copper has a positive ion of +1. So we know that means it's an electropositive metal. Metal lose electron, while non-metal gain electron. So that means copper here will lose 1 electron. If you lose 1 electron, that means the number of electrons now becomes 28, no longer 29. So if I want to answer this, I will let's deal with the silicon first. Silicon is 16. The electronic configuration is 1s2, 2x2, 2p6, 3x2, 3p. That's how many now? 2, 2, 2. That is 10 plus 2, 14. Remaining what? 4. 2p, 3p, 4. That is for silicon. That's the electronic configuration of silicon. Therefore, the copper, it says is 2 Cu plus. That means this one will lose an electron to become neutral. So instead of having 29, we are now dealing with what? This is now 28, no longer 29, because it lost an electron. So if I want to write the electronic configuration, I will write it based on 28, not 29. That means I'm having 1x2, 2x2, 2p6, 3x2, 3p6. That's how many? This is 10. This is 8. That is 18. Then I'm having a 3d10. The maximal number of electrons in the d orbital is 10. P orbital is 6. S orbital is 2. So that is the electronic configuration of the copper ion. You end up with a 3d10. I hope that is clear. Then number 15. So which of the following species has the most unpaired electron? Has the most unpaired electron? Okay, so all you need to do, like, okay, let me use the last question now to just explain it. Like silicon now, I said earlier that the maximum number of electrons that has is always 6. That's the maximum number of electrons for the P. The S is always 2. The D is always 10. So if I look at this 3p4 now, how many? If you compare these two now, instead of 6, we are now having 4. How many unpaired electrons does it have? It has 2 unpaired electrons. It has 2. This silicon has 2 unpaired, because the maximum number of electrons in the p orbital is 6. At the end of the day, we are having 4. That means it has 2 unpaired electrons. So you can use that. I want to leave that one for you. Use that to answer the question 15, and you can put the answer in the comments. Then let's go to question 16. Arrange the following elements in order of increasing atomic radius. Order of increasing atomic radius. We have chlorine, potassium, and argon. We have chlorine. Don't forget, chlorine atomic number is 17. Potassium is 19. Argon is 18. So the atomic radius is derived from the arrangement of elements around the nucleus or shell. For chlorine, we have 2, 8, and 7. For chlorine, this is 7. This is 7. This is 8. Why this is 2? So the atomic radius is from the center now to this point is the radius of chlorine now. Now argon, we also have 3. We also have 3. 1, 2, and 3. So here will be 8. To give us maximum number of electron is 8 here. While here is 2. So the atomic radius is from here also R. Then if you go to potassium, it will exceed 3. Potassium will have about 4 share, not 3. Potassium will have about 4 share. So if you go by that, potassium have the highest atomic radius because it is occupying 4 share. While chlorine and argon, both of them are taking 3. So that means who will come before who? That's the question. And if both of them are taking 3, argon will come before chlorine. Why? Because the valence electron of argon is complete. The one of argon is complete. That is why argon will come before chlorine. Okay. So in order of increasing, I'm going to have chlorine. Chlorine is less than argon. Argon is less than potassium. In another way, potassium is greater than argon. Argon is greater than chlorine. So you can use it that way to represent it, of order of increasing atomic radius. So you can use it that way to depict it. So next question, which is question 17. Give the sub-energy level name of quantum number n equals to 4 and L equals to 3. So we are talking about quantum numbers here from arrangement of electrons. So for 4 energy level n equals to 4 is called 4f sub-level. It's called 4f sub-level. 4f sub-level. Then question 18. Arrange the following in order of decreasing ionic radius. The difference between atomic radius and ionic radius. So this time around we are dealing with ionic radius. Sodium, fluorine, and nitrogen. We're having sodium, which is positive, chlorine negative, and nitrogen, which is negative. So we all know positive ions, they lose electron to become neutral. Negative ion, what happened to them? They gain electrons. This one will also what? Gain electron, but this one is gaining 3 electrons. This one is gaining 3 electrons to become neutral. Chlorine will gain 1, sodium will lose 1. So by doing this, you can now know their sizes when it comes to ionic radius. So those positive ions decreases, while negative ions increases. So between these two, who gain more is nitrogen. That means nitrogen is greater than chlorine. Chlorine is greater than sodium. Nitrogen minus 3, put the sign, minus and plus, put the sign. So that's the concept. But even though chlorine and nitrogen are negative, nitrogen gain more, chlorine and sodium lose more. So nitrogen is greater than chlorine, chlorine is greater than sodium. Then question 19. The chemical bond that holds together the atom of solid metal or alloy is what I was talking about. When you come to mentals or alloy, the bond there is metallic bond. It's simple as that. Bond is simply a metallic bond. It's as simple as that. Then question 20. See, when an electron jump, question 20. Okay, when an electron undergoes a transition from one orbital to another of higher energy level, the result is they're talking about absorption here. It's absorption spectrum or absorption of energy. It's absorption spectrum or absorption of energy. That is the answer.
You are not giving area. We are to read every 2. That is not 2.
Number 21 says Dash proposed that electrons are embedded in a positive sphere. Electrons are embedded in a positive sphere. This is sphere, where you have electron embedded in it. Who proposed that? Is J.J. Thomson. Was the one that proposed that electron embedded in a positive sphere. J.J. Thomson that proposed that concept or theory. So because of time, this is all we can take for today. If you have any questions, you can ask us. Any questions, you can ask us. And please don't forget to support us by subscribing to our channel, STEM of Africa. And I believe your second semester you will enjoy it more because we are starting late. Second semester we are going to do more when we are doing calculus and other things. And you are going to enjoy it more. So if you have any question, ask. You can send it to us if you need further explanation, and always support us by subscribing to the channel. And also you can put the question also as a comment in the comment section. So in the absence of none, I thank you very much for joining. Take care.
Good afternoon. Good evening, friend.
Hello? Hello? Hello?
Good evening, sir.
Evening.
I can hear you.
Okay. Good evening.
I have a question.
Okay.
Good evening, sir.
What's the
Good
question?
evening, sir.
Huh?
And my question is, unlike the exam that you have been written before, that we wrote so far.
Mm.
We discovered we'll be having figure like ABC. For this Chem 101, we
Mm.
now discover that it has changed. So my question is it how this particular question is going to appear tomorrow or other formats?
I know it depends on the examiner. You understand? It depends on the examiner. So this particular question is from Uni Abuja, and depends on your school, but the concept, the content is the same. So it depends on the examiner, how the examiner wants to set the question. Okay, but the content is the same. So the essence of this is to
Okay,
get
okay,
the
sir.
general knowledge of what you might encounter. That's the essence. But the content are the same. The question format might differs.
Okay,
Yes, yes.
okay. Thank you,
Yes.
sir. Thank you, sir.
All right.
Thank you.
Okay, this is a YouTube channel. We are into science, engineering, mathematics, and technology, which is STEM. It's a YouTube channel we are trying to grow by assisting students from various schools to have a basic knowledge. But we are starting late, like I said. By your second semester, we are going to do excellently well when it comes to calculus and the other physics and the chemistry. So we are going to start early so that you'll be well equipped before your tests and exams. So just a little bit, but all the same, I wish you success in your forthcoming exams. But it's a YouTube channel. We call it STEM Up Africa, where we assist schools, students to gain knowledge on. So that's what we are all about. You can always recommend the channel to people, let them subscribe to it, and then I will
Okay,
also
thank
post
you, sir.
video too on our. And then if you also need one-on-one interactions before with us, you can also contact us. Okay. All right.
Okay, sir.
Mm.
All right, sir.
All
All
right.
right.
I hope you understand.
Thank you. Okay.